you can do it without the microphone. Everybody can hear you fine, right? So, just a quick introduction, like what are the stuff that I am currently working on, so that you know what you can also ask me about. So, recently I started working on neural text simplification. Well, everybody are doing neural stuff, so why not text simplification as well. I'm also working on automatic sentence alignment for having these parallel data sets that we need for text simplification. So obtaining the parallel data sets of original and manually simplified text. Then I will talk today about semantically motivated text simplification because it's something that is not so common, but I think it's very interesting as a combination of different areas in NLP. I was also trying to use text simplification as a pre-processing step for machine translations, so to improve the results of machine translation for other resource languages, trying to first simplify the input and then the translation. I also work on complex word identification, automatic assessment of sentence complexity, evaluation of text simplification systems, and recently a conceptual text complexity. Today I will cover the narrow text simplification towards the end of the tutorial, and the semantically motivated text simplification for machine translation. These are mostly topics covered today, but there will be a lot of other stuff as well. So there will be two main parts. In the first part I will try to explain to you what is text simplification. Because I'm usually when I say I work in text simplification, everybody says, is that the same as summarization? What is the difference? And so on. Or I have a friend who works in summarization as well, but it's not exactly the same. Then I will introduce the main motivations for text simplification. I'll talk about existing resources. There are not so many. That's the big problem with text simplification nowadays if you think about supervised approaches. I will also mention what are the problems in innovation of text simplification systems. And then in the second part, probably after the break, or slightly starting before the big break, I will actually focus on automatic text simplification systems. I still think it's very important to cover the first part, what is text simplification, because lately I see as this topic is becoming more and more interesting for wider audiences, that everybody wants to do something with text simplification and then they propose lots of neural stuff there and fancy models, but they actually don't know what is the problem that they are addressing or how to properly evaluate it. So I think it's important to go back to the roots why we do the text simplification in the first place. So in the second part I will just briefly mention the earlier approaches because most of them are rule-based and they're somehow already in history, and then focus mostly on lexical simplification, which lots of people are using today. Mention a few other approaches that I think that are interesting, how you combine different areas of NLP as well, and of course mention narrow text simplification because I guess lots of people are interested in that. So, what is text simplification? One of the definitions is that the aim of text simplification is to transform complex text into a simple variant, taking into consideration the specific needs of a particular target user. So you will see later we do the text simplification either to simplify text for people with some kind of language or cognitive disability, people with autism, dyslexia, with cognitive disabilities, and so on. Or we do it as a pre-processing step for NLP tools and applications like information extraction, machine translation, and so on. So what is the simple variant of a text will depend what is your target population or your target application. The definition and the title of text simplification assumes that we are simplifying the whole text, but what is happening in practice is that most of these systems are actually operating on the sentence level. There are only a few systems that actually take the whole text consideration. Most of them just take one sentence at a time and then try to simplify it. Text simplification is a quite complex task, and you can do it on different linguistic levels. So the two main models in text simplification are either lexical simplification or syntactic simplification. I will mention them soon, exactly what they are. And ideally, as I said, you should do it on the discourse level, taking the whole text into consideration, but I know only of one or two systems that are trying to address this because it's a very complex task. So here is an example of the human simplification. If you give this original text to humans to simplify it, you will get something like this. So you will have the sentences quite short, you might have some definitions added, and if you pay attention to this kind of simplification, you will see that it's very difficult to try to mimic this automatically. This is something that the human can produce, but it's very difficult to get to something like this fully automatically. But this is our final goal, the goal of text simplification. As I said, there are two main simplification tasks. One is a lexical simplification, which means that we replace complex words and expressions by their easier to understand synonyms. Ideally, synonyms meaning cannot always be perfectly preserved, because if you're really trying to simplify some concepts, some nuances of the meaning might be changed, but in general, we are trying to preserve the original meaning. In lexical simplification, we can also explain complex words or expressions by providing definitions and explanations. This is usually the case if we are having some words that are practically the terminology in a certain domain. There is no easier substitute for it or easier synonym, but we rather need to explain this. And in syntactic simplification, the idea is if you have some long, syntactically complex sentence, that you should split it into shorter and shorter sentences, which will have like one main idea per sentence, that will not have some difficult constructions. You might want to change passive to active voice, to split the relative clauses, and so on. And these two tasks can either be addressed separately, as it was done in the first systems. You had separate models for lexical simplification and syntactic simplification, or it can be addressed jointly in these end-to-end systems that are more done nowadays in narrow text simplification, where you just put everything there. It's a supervised approach, and you hope that it will do both things at the same time. So here are some examples. The first example of lexical simplification, so the play was magnificent. If you substitute magnificent with brilliant, or great, or excellent, that would be lexical simplification. Then the second example, this is what I said, some words you cannot substitute with easier synonyms, so you need a definition practically, or explanation that tuberculosis is a disease of the lungs. Then the next is an example of syntactic simplification. So the festival was held in New Orleans, which was recovering from the hurricane, and you see that it's split into two sentences. The last one is the conversion of passive into active voice. This was one of the first transformations done historically in text simplification, because passive constructions are very difficult for certain target populations. So these are the examples of manual simplifications, like the first one. And this is where we are now. These are the results of the state-of-the-art automatic text simplification systems. So what happens in practice where we are is that we maybe change one sentence, one word in a whole sentence, and that's the most of what our systems can do. Or we again just change one verb, but you will see that these things can still make improvement, for example, in machine translation. We were testing, these are the examples you will see later for English to Serbian machine translation, that these kind of changes on the English side significantly improve the quality of the translation, because we can prevent wrong translations of certain constructions that are not common in Serbian language. This is where we are in terms of syntactic simplification when it works well. In automatic simplification, this is pretty much what you can get. And if you pay attention, it's not so, it's not like you really cut it in the middle. There is actually a combination. You have the first part and the third part here in one sentence, and then the middle part is the second sentence. This is the result of the rule-based automatic simplification system. Another type of common simplifications that we can address automatically is this kind of changing the order, how things are presented in a sentence. So one of the automatic text simplification systems always take the part who said what, so like standardizing it so that it's always at the beginning of the sentence somebody said that blah blah blah. And not so often we have content reduction also addressed as in automatic text simplification, which means that we might delete either parts of the sentences or the whole sentences in the text if we assume that they are not so important for following the whole story. This is especially important, for example, if you want to simplify text for people with cognitive disabilities, because they have a problem with the memory load, they have a problem to remember so many information that is presented in a text. They also have a problem to distinguish what is relevant and what is irrelevant. So if we can in some way just keep the most relevant information, that helps a lot. If you would just do the lexical and syntactic simplification, the text even become longer, because when you start splitting sentences, repeating some parts of the sentences, the text that was already one page might become much longer. So sometimes we also want to delete parts that are not so important. Different text simplification systems can address same tasks in very different ways. So here are two examples how two different systems treat the syntactic simplification. So you have here the original sentence. Sorry, the examples are not really the nice with regards to the topics, because they're usually from the newspapers, so the topics can be not so nice. So the first system just do this thing that they said that they always put who said what at the beginning. So just a simple reordering of the parts of the sentence, while the other system is doing a sentence splitting, and even more interestingly, they're changing the tense of the verb because of this split of the sentences. Well, I already mentioned why we need it. So there are two main reasons why. One is simplify text so that humans can understand it better, and we simplify it so that NLP tools can work better if we use the simplification as a pre-processing step. In terms of simplifying for humans, what are the most common target population are non-native speakers, well nowadays even more, people with language or cognitive impairments, and people with low literacy levels. So we are usually talking about better social inclusion of people if we manage to simplify news text or health leaflets. It would help that everybody have access to the information. Initially, text simplification, when it started in the 90s, had the goal of actually improving NLP tools. At that time, machine translation or parsing was not working very well for the complex sentences. So the idea was, if we can first automatically simplify the sentence, then we can improve parsing or information extraction or summarization systems and so on. That was in the 90s, and then starting from 2000, there were several big European projects that were actually aiming now social inclusion. That was easier to track more money for the projects because of this easy use case how to help people have better social inclusion. So, with regards to simplification for humans, there were attempts to simplify text for deaf people, for blind people, for people with low literacy, people with autism. That was a big European FP7 project, simplifying text for people with autism in English, Spanish, and Bulgarian. Then for second language learners, for dyslexic people, for people with aphasia, simplifying text for people with aphasia was one of the first, again, big text simplification projects done in the UK. In terms of languages, of course, the most of the text simplification systems is trying to simplify English texts. That was from the beginning. That's where we have most data, especially given that we have English Wikipedia and the simple English Wikipedia. I will come back to that later, but there were also attempts for other languages. For Portuguese, there was also one big project for simplifying texts for people with low literacy, so in Brazil. So there was quite a few works done then for Portuguese text simplification, and there was a big project in Spain for simplifying text for people with cognitive disabilities, for people with Down syndrome. So that's also like a big chunk of work done for text simplification in Spanish. In other languages, it's pretty much here and there a few works trying to attempt text simplification. For NLP applications, as I said, originally the idea was that it will improve machine translation and parsing, later information extraction, and then semantic role labeling. And these things somehow got forgotten because machine translation and parsing and information extraction, they all managed to get better and better results even without text simplification, so nobody's tried nowadays really to use text simplification as a pre-processing step. And I think also they were very optimistic, thinking that automatic text simplification is actually easier than improving these systems, and nowadays we see that automatic text simplification is not so easy to achieve without mistakes, and therefore it's tricky to use it as a pre-processing step. So, as I said, the first project addressing text simplification for people was to simplify news articles for people with aphasia. Aphasia is the state some people have after the stroke, for example. It changes the way how you understand the text. So people would have a problem with less frequent words, and especially with some sentence constructions that are like passive constructions, so that they don't have this subject-verb-object pattern. So if they see the sentence like the boy was kissed by the girl, they wouldn't know who kissed whom. Did the boy kiss the girl or the girl kiss the boy? That's why the first text simplification systems were always having this conversion from passive to active voice. And they also have problems in news text with these long sequences of adjectives or nouns, which is quite common in the news articles. The other big project was simplifying text for people with autism spectrum disorders. It was aiming autistic people, but with a high IQ. So people who might have a PhD and high degrees, but still they have some problems in processing ambiguity in meaning and some structural complexity. Mostly they have problem with semantics, with ambiguous words and phrases, with metaphors that are not so usual, anything that has this figurative meaning. And this I would like to show you because most of you, I guess, speak Russian, and I guess that these things might hold for Russian as well. We were doing tests for English to Serbian machine translation, and I mean, Serbian is very similar to Russian. So we did it from, out of pure curiosity, just because we knew that it was the first reason why there was a text simplification in the first place. So we said, okay, let's take now state-of-the-art automatic text simplification systems in 2016, try to apply them on the sentences in English, and then do the machine translation from English to Serbian and see if it helps. Because Serbian is under-resourced language, it has also 7 cases, complex syntax and grammar, and it's very different than English. So we tried 2 different text simplification systems. The first one is a more traditional system. It's a combination of the rule-based syntactic simplification and supervised lexical simplification. This one doesn't do any content reduction, so it completely preserves the original meaning. And the second one you will actually see later. I will explain both components in details. It has this unsupervised lexical simplification that is based on word embeddings, and it has, again, unsupervised syntactic simplification based on the detection of events in text. So this one performs syntactic simplification and content reduction, as well as some lexical simplification. So you could say this one, the first system preserves completely original meaning, the second one can change it slightly because it is trying to delete irrelevant parts of the sentence. So what we found, if you check the fluency and adequacy of the translations later, but I'm not showing here the Serbian output, so the final result, but I'm showing you here how is the changed input sentence. So if instead of this input sentence, we put this one, which is automatic simplification of the first one, the thing is that the accuracy and fluency, adequacy and fluency scores will be higher, so the translation will be better. And what was happening here, it's just the reordering of the certain sentence parts, but it seems that this structure of the sentence is much better translated into Serbian than the first one, probably closer to the Serbian language structure. The second example, you saw it at the beginning when I said where we are in terms of automatic text simplification, that even if you just change this side on, and instead of it we say that they choose a new embassy location, we improved a lot adequacy and fluency of the translation. Because in Serbian we don't have these constructions, so that then the preposition becomes funny and the whole sentence, as it's long, gets much less grammatical, and it might even change the meaning. Another example of successful simplification is here when we split the sentence and we also change this turning, before turning the gun, this ing construction, which again doesn't exist in Serbian language. Once we have this sentence split into 2 and we don't have anymore this ing form but just a simple past tense, then we get the perfect automatic translation into Serbian. Okay, so this is pretty much where we are now, so that you have an idea what the text simplification systems can do and why we do this. If we talk about simplifying for humans, as I said, it could be for different types of, for people with different types of disabilities or language disabilities or cognitive disabilities. And it's an interesting question, can we address all these groups at the same time? How much their needs for simplification are similar or they're different? And in general, people just start from some simple, easy to read characteristics. So there are lots of guidelines from the 90s that tells you how to produce simple text for people with low literacy level, with cognitive disabilities, language disabilities, and so on. So these are general rules that are starting point for simplification towards humans. And then once you know who is exactly your target population and which language you are addressing, then you need to go much deeper into this and to make these rules even more specific. So some simple things are that you need to use a simple, straightforward language, only one main idea per sentence. That's for everybody, and that's the reason why we do the sentence splitting, to have short sentences, each one with one main idea per sentence. That you should avoid technical language, abbreviations, initials, and that you should have a clear and logical structure. This is maybe one of the most important things for everybody. Unfortunately, news texts usually don't follow such structure, and unfortunately, text simplification systems still do not do so much of the reordering on the discourse level, but probably that should be the main task if you really want systems that can help people understand text better. So just to have an idea what these guidelines say, they tell you avoid abstract concepts, use short words that are used in everyday spoken language, use personal words, so directly say you should do this instead of user should do this and that. Use short sentences, but they all also tell you, be careful. I mean, writing a simple text doesn't mean talk to adults as if they were kids, and don't change the vocabulary to the kids' vocabulary. It should still be respectful, but you should just be careful how you use certain expressions. Use active rather than passive verbs. Avoid negations. Some people would also have a problem with negations, and if you think about double or triple negations, even more. Keep the punctuation simple. Do not use subjunctive tense, but rather be direct in terms of tense as well. Be careful with figures of speech and metaphors if they are not commonly used. That, as I said, it's a big problem for people with autism, for example, but could also be a problem for non-native speakers or for children. Be careful with numbers. This part will differ depending on your target population, because for some you just don't want to be over specific. You can just say a long time ago if it was a long time ago, or just a small percentage instead of giving the numbers. But then again, it depends on the main information in your text. If you really need to tell exact numbers, then tell exact numbers, but if they're not important for the story, then you might want to avoid them. And don't use words from other languages. Now we come to the part, and I say when I mention text simplification, everybody asks me, is it the same as summarization? Is it the same as, well, there are some approaches to text simplification using machine translation. So I'll try to give simple answers to that. There might be some overlap of simplification and summarization, but that's not so common in text simplification. So simplification tries to keep the sentences very short, very simple, and to have a simple vocabulary. And that's the main goal of text simplification. In summarization, you are deleting irrelevant information, keeping the most important one, but that can also make your text be more dense and actually more difficult to understand, because you have more information in a shorter chunk of text. And that will be completely opposite of the goal of text simplification. What they have in common is when text simplification is also doing some content reduction, so deleting irrelevant parts of the text, then you could say that this simplification within has some kind of summarization. But it's not really possible to do summarization and then simplification or the other way around, because none of the systems is great. If you would apply on the text first summarization technique, you will probably get even more complex sentences, and then your text simplification system will not work on those. And if you do the opposite, if you first try to simplify the sentences, then you will get probably not so grammatical output and some changes meanings, because automatic text simplification is still not good enough to have a good output without any human post-editing. So if you do first automatic text simplification and then you try to do summarization, you will probably get lots of errors in summarization, because you're dealing now with changed meaning and ungrammatical sentences in the first place. So the idea is, if you're addressing something here in the middle, you should jointly do simplification and summarization at the same time. Then also I have seen papers stating we are doing sentence simplification, but they are actually doing sentence compression. Sentence compression and sentence simplification are not exactly the same, so again, it's a similar thing as before. Sometimes in simplification we delete certain part of sentence, and that's some mixture of simplification and sentence compression. But sentence compression in general doesn't need to make the sentence simpler, it just makes it shorter and more dense. And starting from 2010, there were lots of attempts to model text simplification by using whatever we had in machine translation, thinking that, okay, text simplification can be seen as a monolingual machine translation. Practically, instead of translating from one language to another, you are translating from original language to the simplified language. So it can be seen as machine translation. You can use Moses, so the phrase-based SMT. You can use syntactic-based SMT. Nowadays, neural machine translation. But it's important to keep in mind that it's still monolingual machine translation, that the evaluation will be different, and that you will need to tune your system so that it works in this monolingual case. And I think what is most important here is a difference between text simplification and other tasks. In machine translation, in summarization, most of those tasks, you want your system to work for the most frequent cases. If you address well what is frequent, your systems work well. But text simplification is actually interested in that long tail. Especially if we are simplifying for humans, what we want to simplify are infrequent phrases, infrequent constructions. So that makes the task especially difficult, because we exactly want to attack those things that we don't have enough evidence for and we don't have enough training data for. So what we have from the resources, very few resources. So the big problem for supervised text simplification. From 2011, we have this automatically aligned English Wikipedia and Simple English Wikipedia. I guess most of you know. If you don't know, you can also search for the terms in Simple English Wikipedia. For English, it exists. For Spanish or for German, for example, there is no Simple Wikipedia. But for English, there is. So people automatically aligned the text by matching the topics in English Wikipedia and Simple English Wikipedia, and then also automatically aligned sentences, and in that way build big training material. I mean, big for the text simplification purposes, around 167,000 sentence pairs. For text simplification, that's a lot. I know for machine translation, for other tasks, it's not. What is the problem with this data set is that Wikipedia articles and Simple Wikipedia articles are usually written independently. It's not that somebody who is writing the Simple Wikipedia article is looking at this original article and then trying to simplify. he might be, but we cannot be sure about it. So we are just hoping that these topics are similar, and then there is automatic alignment of sentences, and we hope that the sentences coming from simple Wikipedia are really simpler. Then in 2015, this data set was even more improved because they distinguished, first of all, the size of the data set became larger because it was more simple Wikipedia articles. But also what is important, they were distinguishing between full matches and partial matches. They noticed that sometimes the sentences from simple Wikipedia, they just have the part of information of the sentence in original Wikipedia, and having this clear cut between full matches and partial matches allowed us to model both sentence paraphrasing and the content reduction separately. Here is what I'm talking about. If you look at the English Wikipedia, and so these are the sentences from English Wikipedia, and these are their aligned counterparts from simple English Wikipedia. This is a sentence-wise low score, so just to give you an idea about the n-gram overlap, let's say, in the sentences. So, as you can see, we have very strong paraphrases here, and we have some just lexical simplification found here, or a sentence splitting found here. So, this data set gives you all these kinds of transformations, and then you can use it as a training data set and either try to separate these different transformations and model them separately, or you just put everything that you have and hope your system will learn something interesting from that. This is the refined version of Wikipedia. So this is when you have the difference between the full matches and partial matches. So depending on, is there a full semantic overlap or just a partial semantic overlap. So this data set explicitly tells you full or partial and allows you to have different training data sets for different kinds of transformations. So this was the first time, 2011, when it started, using the simple English Wikipedia, that you have a large parallel data set for training text simplification systems, and it was the only big data set for such purposes, only for English, but it has few shortcomings. There is no quality control of simplifications, so you have guidelines how to write for simple Wikipedia. It says use short sentences, use frequent words, try not to use strange construction and so on, but there is nobody actually checking did the writers comply with these rules. We don't know if they're direct simplifications, we cannot assume that, and we have automatic alignment, which also is imperfect and might lead to just having some simple transformations captured and not being able to model some others. There are corpora that are really with a good quality control that were done by trained human editors who were given the original versions. They knew their target populations. They have guidelines that are 100 pages long and telling you how to simplify for this target population. But these data sets are very small because this is a very time-consuming process. So there was this, as I said, big project in Brazil, simplifying text for people with low literacy levels, and the size of this data set is approximately 4,500 sentence pairs. It's a good quality control. We know what kind of transformations they are, for whom they are. We know that it's a direct simplification. There is a good quality control, but it's very small. Similar thing with Simplex project for Spanish, aimed for people with Down syndrome. This dataset only has 2,000 sentence pairs. So you could use these datasets maybe as a test set or starting point for your systems, but there is not enough data for fully supervised systems. Since a few years ago, there is this new data set, but it's a web page also, this Newsela company in the States, who are simplifying news text for children and for language learners. You have the original text, news text, then simplified to 5 different complexity levels. They are manually simplified, there is a good quality control, so you always have the original text and then slightly simpler version, more simple version to very simple version. It has more than 2,000 English news stories and 250 Spanish news stories, so it's not only for English. These are the numbers from the dataset in 2016. They're preparing another version to release for research purposes, which should be bigger. There is a good quality control, strict guidelines. It's freely available for research purposes, but not for commercial use. You have to request it on this website, and then you can use it. And at the moment, there is only one version from 2016 that all of us use it, so at least we know that we have comparable portion of Newsela. This is how it looks. So you have the original text. This is just one paragraph from original text. Texts are actually much longer, the original text. And then you have 4 simplifications of it. And as you can see, the simplest version is really with short sentences and very easy vocabulary. When you request Newsela dataset, you just get it as a text-aligned dataset. It's not sentence-aligned provided. So you have some portion of it manually aligned by Shu and her group in 2016, and you can ask her if you have the Newsela dataset. They can provide you with the manual alignments. And there were 2 systems for automatic alignment. Once we released in 2017, and the other one was by Gustavo and Lucy also in 2017. So they're both freely available, and you can try to align. It's for English. We also tested our system for aligning Spanish Newsela, and it works very well. So these are the 2 systems. Ours and Gustavo's and Lucy's, they're both freely available, and you can use it either for aligning Newsela or any other parallel text, monolingual text. What is difficult when we try to align these data sets, we were trying to manually align Newsela to have the gold standard. Be careful with this. It's not an easy task. You have this original text, and then you have another version. If it's just the first level of simplification, it's not so difficult to say which sentence corresponds to which one. But deeper you go, the simplifications are done from level 0 to 1, and then somebody else did from 1 to 2, then from 2 to 3. No matter how good are their guidelines, if you try to align the 0 and the 4th level, it becomes some kind of end-to-end matching, because the idea is across several sentences here, several sentences there, and it becomes very tricky to say which sentence corresponds to which one. So if you ask me, try to do it with 3 or 4 annotators, and the agreements were very low how they would make the gold standard. So instead, what is more commonly done is you do your automatic alignment, and then you just give the sentence pairs to humans and ask them, is there no match, is there partial semantic overlap or a full semantic overlap, and that's where the people agree. This is case for all very severe transformations that are sometimes needed. In the simplex corpus, also it was a problem how to make the gold standard, because you have very strong paraphrasing and you're not sure which sentence corresponds to which one. There are a few more data sets that were crowdsourced. Text simplification, they're all dealing with lexical simplification only. There is this data set from 2014 which consists of 500 Wikipedia sentences, where the mechanical Turkers were given the sentence and one target word in this sentence, and they were asked to provide simpler synonyms for this target word. So there were 20 people providing what they supposed to be simpler synonyms. And this dataset is commonly used for evaluation of lexical simplification systems. This is another similar dataset for lexical simplification, where the non-native speakers were again asked to provide simpler synonyms. And this dataset from 2016 has again sentences from Wikipedia, but here the mechanical Turkers were asked to provide a full sentence simplified, but to focus on lexical simplification. And this one is commonly used for all supervised systems. So there is usually this portion that is used for development, as a development data set, and this for testing. So if you want to compare your systems with somebody else's and the state of the art, it's common to use these data sets, and it's actually a very good idea to use it because most of automatic text simplification systems are not freely available. You might need to ask authors to run it for you. Rarely people really release the software, so then your best way to compare with their results is actually using the same test sets, because their systems are not freely available, but everybody released their output on these test sets. So that's a good way to have some comparison with existing systems. And let me just see how we're doing at the time. So we are supposed to have a break at 11:30, right? Do you need a short break now? Do you want a few minutes break, or I continue for 1 hour and a half?
That's okay.
Continue. Okay. But you can always stop me and ask me. As I'm moving from one topic to another, you can just stop and ask on the way. So, evaluation of text simplification systems, it's a very, very tricky area. Unfortunately, I would say there is not much done in this direction, as it's fairly new area, fairly new, 20, 30 years old, and it looks so similar to other areas like machine translation or summarization. People are just adopting their evaluation metrics without thinking, do they really make sense for our tasks? And that makes it very difficult to compare the systems. As I said, for the lexical simplification, you have these few data sets that you can compare automatically to other systems. The problem is that it's only 500 sentences or something, so you're not really testing for the right coverage and for different domains. But in general, the main idea how you should evaluate text simplification systems is for their effectiveness or usefulness for your target population. So for the reading speed and comprehension. So ideally, when you simplify text, you want people now to read it, to check their reading time, to see how they understand. Do they now understand it better? Do they read it faster? So either you need to do it using some comprehension test, or you might use eye tracking and check where the old problems resolved. That's almost never done in practice. It's very difficult and time consuming, and also depending on your target population, you might have a problem to access. Some of them are vulnerable populations, so that you need special permissions to test how they read and understand. And also these vulnerable populations, they might be affected by the fact that they are now asked to solve the comprehension tasks or to read something, and you get artificial results because they're actually not acting naturally in this specific environment. So what is done normally is just assessment of the quality of the output of the simplification systems. And there are two ways to do it. Either automatic evaluation or human evaluation. They're usually done jointly. Without a human evaluation, I would say this is not really enough for you to say that your system works well. First common thing that people use is readability measures. I don't know if you heard about these readability scores like Blasch-Kincaid score or any other readability metric that there is. They're very simple measures that take into consideration average sentence length, average word length, and these metrics were proposed to check are the school books at the adequate level for the school kids. First of all, these metrics are supposed to be used on manually generated text because they're just taking into account sentence length, word length, some simple metrics like that. They are actually not valid on an automatically generated text because you might have completely ungrammatical sentence without any meaning, and these metrics cannot capture that. So that's a big caution not to use readability measures if you didn't check first that you preserve the meaning and that you have grammatical sentences. The other problem with the readability measures, they are assumed to be applied on the text level, not on the sentence level. They make no sense on the sentence level. Their coefficients before the factors are done so that they make sense on the whole text but not on the sentences. And we see lots of people trying to apply this on the sentence level, and I would say this is a very big misuse of these metrics for text simplification. Those text simplification systems that are using empty approaches, they are also commonly evaluated by using empty evaluation metrics like BLEU score, Meteor, and so on. Most commonly BLEU score. Do you all know what is the BLEU? Okay. So the BLEU score is most commonly used evaluation metric for machine translation. Is practically the n-gram matching between your translation and the gold standard translation. So if you have two sentences in the same language, it's practically some kind of n-gram matching, usually to up to 4 grams, how much of the overlap there is. And that makes sense in machine translation if you have many gold standards. So if for each input sentence you have 5, 6, 8 human generated translations, then that your output, you check how much overlap it has with this gold standard. But in text simplification, we first of all don't commonly have the gold standard, and if we do, we have maybe one sentence, and that's why this metric, and I'll show why else, also is not maybe the best way to do it. Could be useful as one of the evaluation metrics, but not on its own. So this is pretty much what everybody does and what is the most reliable evaluation for text simplification. That is done on sentence level, but as I said, most of the systems also just work on the sentence level, so it's not such a big problem. What you do here, you ask human annotators to assess grammaticality of the output sentence on the 1 to 5 level scale. The meaning preservation, so showing the original sentence and the simplified sentence is the meaning preserved, again on 1 to 5 scale usually. And how simple is the sentence, your output sentence. So here is an example. So if you have, this is the original sentence that we want to simplify. So of course it's grammatical, so 1 to 5 scale, 5 is the best. It's fully grammatical. Simplicity was assessed as 4. This is a very tricky thing. If you have this absolute assessment of simplicity, what each annotator would assume that is simple or not, it's a difficult task. Usually have only 2 to 3 annotators. You report their agreement. you should ideally try to have a native speaker evaluating grammaticality and meaning preservation, and non-native speaker evaluating simplicity. But that's not always done in practice, and it's a big mess, I would say, in evaluation, because if you have a non-native speaker who doesn't understand fully the original sentence, how can this person say, is the meaning preserved if he doesn't understand both sentences? And on the other hand, native speaker who fully understands the original sentence might not notice that there was something simplified, and that the simplified version is easier if the first one was easy for them. But again, okay, so this is original sentence. These are the scores, the average scores of 3 annotators. And then you have 3 different outputs of the text simplification systems. Assume that you are trying to evaluate 3 different systems and to see which one is better. And you see here there was one change. Troops were substituted by his soldiers, and this made the grammaticality a bit damaged. Meaning is not perfectly preserved, and simplicity was assessed as the same. Here, for example, there was also just one lexical change. So instead of someone was installed on the throne, the output of the system says that this person was put on the throne, and this was assessed as much simpler sentence than the original one, just thanks to this one lexical substitution, which did not damage grammaticality and didn't change the original meaning. Here there was one change, but that damaged the grammaticality, changed the meaning, and no matter that you say to people not to penalize simplicity by grammaticality of the sentence, if the grammaticality of the sentence is severely damaged or sentence has no meaning, they will have to penalize it when they assess the simplicity. Yes?
Can I ask you, if this version have 5 for simplificability, could it be simplified more? So is it the highest points, 5? So does it mean that there is nothing to simplify at all?
That depends how you make the guidelines for the annotators. Yeah, that's a good question. You can look at it that way, but usually it's not what we mean by that. Usually ask them to try to make as many distinctions between the similar sentences as they can. So we artificially push them to have the differences. If you have, they're always given original sentence and then let's say 5 or 6 different simplification outputs. And we tell them if they feel that one output is more difficult than the other, that they should then make the difference in the scores. So actually these scores, I wouldn't say that they are perfect on the absolute scale, but more like relatively. If you compare one output and the other, do you have the score going down and going up when you compare original sentence with the output, or if you compare several outputs of the same, of different systems, but for the same original sentence.
So the 4 is a kind of median value when nothing was changed, and 3 is a lower result. So there is a bias towards to 4.
Usually we say 4 and 5 are already good. The thing, for example, here, why you have such a, I guess this that got 4 doesn't look so simple, but the point is when we give them 100 sentences to evaluate, there were sentences that are super long and super difficult, and then they had to give them 1 and then 2. So it depends on your data set that you give to evaluate. If the sentences are simpler, then the whole, scores will be biased towards one side. And here, as it was, I think, from Wikipedia, we usually work with Wikipedia and news text. There are always several sentences that are extremely difficult. They got 1 and 2, and then most of the sentences at the beginning, like original sentences, got 3 or 4. That's usually the starting point. But also the systems, automatic systems, as you see, they don't do much simplification actually. They do only a few changes. So then, as I said, you don't care so much what is the starting point. You're just checking, is it going lower or higher from the original when you want to assess your system. And that's usually where you get a good agreement. You don't get agreement of the evaluators on the absolute scale. Maybe somebody gave here 4, 4, 5, 3, and the other one gave 2, 2, 3, 1, but it's still the same. It's still the same distance, and then so you're actually checking if all of them agree that this system improves or that this system damages the original sentence. That's the way to overcome this very subjective feeling of what is simple and not. There was an attempt in 2016 to do this automatically, so to replace the human assessment of the quality of the output with automatic assessment. So we organized a shared task, and so the examples were like these ones, and so the systems were supposed to predict the grammaticality, meaning preservation, and simplicity. And there were 20 classification systems and 12 role metrics that were proposed. And the best systems were combining empty evaluation metrics like Blue score or Meteor score, and some baselines from machine translation quality estimation features. So we borrowed most of the features from machine translation, and they seem to work the best. But still, none of these systems have a very good score. So you had here like 72 for like a measure for the grammaticality, 68 for meaning preservation, and 56 for simplicity. So of course grammaticality is the easiest one to predict, but simplicity is the trickiest. And I would say none of these systems, not even the best ones, are still good enough to replace the human evaluation. But there is a data set and people are still trying to improve these scores. Okay, so here we start the automatic simplification. So far you know what it is, you know the problems in evaluation, you know what the data sets are there, and now let's see how the systems actually look like. So, as I said, why there is a motivation for automatically doing it, there's lots of people doing it manually. You have specialized websites for simple news for people with different disabilities. Pretty much every language will have some web page where the news are also produced in a simple version. But this is a very time-consuming process, and it can be done only just for a few articles per day. But if we want to do it for more articles, we need to do it automatically. So that's like the reason why we started addressing this automatically. We're still not even close to the manual simplification. Of course, there are two main ways to approach text simplification: by rule-based systems and data-driven systems. At the beginning, so in the late 90s, most of the proposed systems were rule-based. At the time there was not enough data. There were not parallel data sets or data on text simplification to use any data-driven approaches. So all systems were rule-based, which means that they're very time-consuming to make, and they're language and genre specific. To make rule-based text simplification systems, you need native speakers who are linguists and who know how to simplify it, and still you will end up with, 40 rules for just converting passive to active voice, or 50 rules just for converting relative clauses. And this is only for one genre. If you change the domain, if you change the language, then you need to do everything from scratch. So that's a big problem with the rule-based systems. From 2010 2011, with the Simple English Wikipedia, there are more and more data-driven approaches. And also with this other text simplification big projects that were treating text simplification, that were focusing more and producing some manual simplifications. And that, in 2014, they tried the hybrid approaches, because what was seen is that these rule-based approaches, they're still much better than the data-driven approaches for syntactic simplification. If you remember that the simple Wikipedia and original Wikipedia line corpus has around only 170,000 sentence pairs, you will see that it's very difficult then to learn how to do syntactic simplification well from such a noisy and a small data set. But what data-driven approaches were better at is lexical simplification. They had a better coverage for lexical simplification. Rule-based lexical simplification is basically what you go through the sentence, you find words that are infrequent, so they have low frequency score in some large corpora, or they have a low familiarity score in some psycholinguistic databases, and then you try to look for their synonyms in WordNet, find their synonyms, see if these synonyms are more frequent and if they're easier to understand according to the psycholinguistic databases, and that's how you do the lexical simplification. The problem is that the coverage of WordNet and even more psycholinguistic databases, it's very small, and as we said, we are actually interested in these infrequent words, so it's very likely we don't find them in the databases. So the rule-based systems were really bad for the lexical simplification, as they didn't have a good coverage. Data-driven systems had more data to work with, so their lexical simplification model was better. So there was an idea in 2014, let's have a syntactic simplification model that is rule-based and lexical simplification model that is data-driven, and this is the current state-of-the-art, let's say, overall. It was the system that you saw at the beginning, doing both syntactic and lexical simplification. Among these data-driven approaches, in 2010 appeared this machine translation-based approaches, so with the idea of why don't we use Moses, just instead of feeding two different languages, we feed them with the parallel sentences that are originally manually simplified ones. And since 2017, also the narrow machine translation approaches. And there were some ideas of using tree transduction, so from English Wikipedia, Simple English Wikipedia, learning how to change the parse trees so that you do the simplification, but they had lots of errors and not enough coverage, given that we have a very small and noisy data set. So if we talk about automatic text simplification in general, there are three main stages. The first one is to detect what are the necessary transformations. So if you're given the original text, you know what is your target population or target applications, which kind of transformations you want to model. The second stage is to actually build such systems, such models, and the third stage is to evaluate it. How we detect necessary transformations? Well, it depends, are we simplifying for humans or are we simplifying for NLP applications? If you're simplifying for humans, there are different ways to do it. At the beginning, for the rule-based systems, the ideas of how to transform the text was based on psycholinguistic theories. So we knew from psycholinguistic literature what are the problems that people with cognitive disabilities have, what are the problems with autistic people have, what are the problems of dyslexic people, and then we try to model those transformations. With a emergence of simple Wikipedia, there was another way. Let's have these parallel data sets. We have original text, we have simplified text, and we check what they share and in what they differ, and from that we try to learn what kind of transformations we have to do. Ideally, I think we should use eye tracking, but that's very difficult and time-consuming thing. Do you all know what eye tracking is? So like when you have this device that is actually checking where your eyes are looking while you're reading the text. So you're sitting in front of the computer, but you can do it with the glasses as well. But usually you're sitting in front of the computer, you're reading the text on the screen, and there is something that is recording how your eyes are moving on the screen. So this is really good to detect actually your objective feeling, what is difficult, because you can see where you are going backwards, where you stop, where you spend more time focusing on, and that will tell us what are the problems for the reader. The problem with this is that recording eye tracking data is very long and very difficult process. Then there are lots of things done on crowdsourcing. This is much easier. You just put your sentences to Amazon Mechanical Turk and ask people to highlight what is difficult for them, or you give them target words and ask them are they difficult or not. And another version which is actually quite popular is to treat everything as potentially complex. So forget about all these complex strategies, what to transform, because we see that our automatic text simplification systems are not actually doing much transformations. Let's just try to simplify as much as we can and see does it help anyone. This is more like NLP approach. And for NLP applications, ideally you should learn which transformation you need by checking the system's mistakes. So if you want text simplification as a pre-processing step for machine translation, you should see what your machine translation system, which type of sentences or which type of constructions or which kind of words it has problems translating, and then you would attack exactly those constructions and those words and build the systems to simplify that. What is happening in practice is, again, we are skipping this huge error analysis step and we just try to simplify as much as we can and hope it will help some NLP application. And then when we go to the second stage of building the text simplification systems, there are two main approaches again. You can either build a modular system, so for each type of transformation you want to model, you practically have a separate module in your system that you can then kind of use or not use depending on who is your target audience. Or you can build end-to-end systems, which is most empty-based systems. You practically give large training data set, you have something that is more or less a black box, like phrase-based SMT or NMT, and then you see what comes out, what kind of transformations there. If you're using the modular system, it's typical to have a lexical simplifier, a syntactic simplifier, and then, this is happening only sometimes, have a module for adding information or definitions. Like we said, for some terminology like tuberculosis, you cannot just replace it with a synonym, but you add a definition. Or for elimination of certain sentence parts of full sentences, you would have a model for content reduction or elimination of unnecessary parts. And as we already said, for evaluation, for the third stage, you have quality assessment of the output, and you have automatic evaluation, and ideally you should check for usefulness. This checking for usefulness only happens in big projects, usually towards the end of the project, that you actually ask the real users, does this system help or not? What are the biggest problems nowadays still in text simplification is that parallel corpora or training your systems are very rare and they're small in size. And especially if you're talking about simplification for some specific target population, because Wikipedia, simple English Wikipedia, it's kind of for everybody. But if you want to simplify for dyslexic people or autistic people, you need parallel data sets aimed for them. Another problem, connected with that is that these systems either need huge number of rules, handcrafted rules, as I said, 40 rules for appositions, 40 rules for relative clauses, 40 rules for passive to active voice conversion. So imagine how difficult it is to have it for each domain and for each language. Or they need large amounts of parallel data so that you can build this empty-based text simplification systems. Another big problem is that existing systems do not perform enough content reduction. If you check what the human editors are doing, they are deleting a lot of irrelevant information, but that is very difficult to model automatically, and there are not many systems who even try to do it. And another big problem is that there is no well-established methodology for evaluating, as I said before. So it's very difficult to say if your system is better or worse than some other system. You don't have access to those systems. They're not freely available to test them for your new data set. And also, you are using this human evaluation depending on who is your evaluator. This scale might be different, just what we talked about. Would somebody say that this is ranked, this is marked as 4 for simplicity, and maybe in some other study the same thing was marked 2 for simplicity. It's very difficult to compare those numbers. You practically need to do the assessments for all the state-of-the-art systems and yours from scratch to make sure that it's the same human annotator doing it on the same scale. Okay, let's finish this before the break. I will very briefly mention early approaches, just so you have an idea what were the first ideas. Because usually when we now listen to the talks about narrow machine translation, narrow text simplification, or some new approaches, everybody says, oh, but have you tried using WordNet? Have you tried doing this or that? Yes, it was tried in the 90s. So the common architecture in the late 90s was you have a text, you apply lexical tagger, morphological analyzer, parser, and then you get the analyzed text. And then you have two different simplification models. One is syntactic simplifier, the other is the lexical simplifier. You apply these on the analyzed text and you get some output. They were heavily depending on the part of speech taggers, morphological analyzers, and parsers. This is the architecture also of most of the early text simplification systems. Advait Siderton was doing his PhD on text simplification. He's one of the first people who was addressing both syntactic and lexical simplification, and still the state-of-the-art syntactic simplification is his rule-based system. So it's a similar idea. You have we are talking here about the sentences. So you have the input sentences, you analyze it, you can use chunking, parsing, part of speech tagging. Then you would have the transformation rules. So these are manually written simplification rules, as I said, for apposition, for relative clauses, and so on. So in the analysis, you will detect what kind of sentence it is. Let's say it has a position, then you will apply the transformations for your transformation rule for apposition. You will do this, then you will regenerate the sentence, and you will apply these transformation rules as long as you can apply any syntactic transformation rules. Once you're done with syntactic simplification and no other rules can be applied. Then you go to the lexical simplification model, where you will do the word sense disambiguation and dictionary lookup to find synonyms or paraphrases that you can use to replace your phrase. And then you will get the output sentence. Pretty much all systems have that. What they were differ in is what are the transformation rules they have, depending on the language, depending on the domain, and depending on the target population. Also, where they have this dictionary lookup or word sense disambiguation, but the general architecture was pretty much the same. You had these several models, you had analysis of the text, transformation, and regeneration phase. This is just so that you have an idea how many words there were. I don't want to go into details, but starting from 94 to 2014, these are just the most cited ones, I would say, or most interesting ones. Most of them were done for English. As you see, as a target, some of them had NLP tools, machine translation, semantic role labeling, but most of them were for specific target population as aphasic, language learners, low literacy levels, children. General or various means probably it's done for Wikipedia and we don't know who is the exact target population. And in terms of tools that are used for analyzing the text, there is lots of differences here, which kind of part-of-speech taggers, parsers, word nets, dictionary lookups, morphosyntactic analyzers, and so on were used in these works. But after the break, then we go to more recent, like the state-of-the-art nowadays for lexical simplification and for narrow text simplification. I think we can do the break, right? Okay, so let's start with the second part. So now more recent text simplification systems. We'll start with lexical simplification. This attracts more attention lately, but it's easier task of the two. As you saw, syntactic simplification, it's very difficult. It either needs a huge number of handcrafted tools, or it would need much larger data sets than what we have right now. But lexical simplification seems as a much easier task to address and also to evaluate, given those few evaluation data sets we have for lexical simplification. So most of the people recently addressed this task only. So when we talk about lexical simplification systems, we have two main types. So similar as for text simplification in general, so for the lexical simplification systems, you can either have a modular approach to it, so having different stages of lexical simplification addressed separately, or you can have all-in-one approach. If you have a modular approach, you normally have these four components. The first is complex word identification, which means first let's find which words we need to simplify. Not to try to simplify all words in the given text or given sentence, but first see what should be our target words. There were also two complex word identification share tasks recently. So in 2016 there was a seminal complex word identification task, and this year at BEA workshop at NACL was another one. In 2016 it was done only for English. In 2018 there was a shared task on complex word identification for English, Spanish, and German, and also distinguishing between native and non-native speakers. That's also a task on its own that attracts attention, but it's also the first step in a modular approach to lexical simplification. Once we know the target words that we want to simplify, we need to generate possible substitution candidates list. Once we have this list, we need to rank them to see which is the best one to substitute, either because it preserves better meaning or it's simpler than the original word. And finally, we need to substitute it and to make sure that the sentence is still grammatical when we make this lexical change. So, historically, in the late 90s, there was the first lexical simplification approach that was based on the WordNet. As I said, these first approaches, they would have some kind of frequency count or checking in the psycholinguistic databases, which are complex words. These would be seen as target words. Then WordNet would be used to retrieve the substitution candidate list. And then this list would be ranked based again on psycholinguistic databases for the frequency counts, and then it would be replaced. In 2010, again with starting to use the English Wikipedia and simple English Wikipedia, in 2010 it was used only English Wikipedia metadata for unsupervised approach to lexical simplification. They were using the edit histories. So they were assuming that if you are changing some word, then you are actually trying to make it simpler and easier if you make the edits in Wikipedia. So that was unsupervised approach to lexical simplification using English Wikipedia. Then in 2011, similar idea, but using English Wikipedia and simple English Wikipedia, but they were not aligning the two corpora, but they were checking the co-occurrences in the original Wikipedia versus in simple Wikipedia and try based on that to figure out what is a simpler synonym. In 2014, there was the first supervised lexical simplification system based on sentence-aligned English Wikipedia and simple English Wikipedia. In that same paper is the data set for evaluation that I was talking about, that was consisting of 500 sentences from Wikipedia with one target words in each, and the 20 mechanical workers were asked to give a simpler substitution candidate. So this is the paper that introduces both, at that time, the state-of-the-art supervised lexical simplification and the new evaluation data set for lexical simplification. In 2015, we introduced the unsupervised lexical simplification approach, as at that time word embeddings started being popular, and we said let's try to use them, and then we don't have to rely on simple corpora. In 2016, very similar idea by Gustavo and Lucia, again using word embeddings. I will mention what are the main differences between these two systems, but you can think of them like appearing at a similar time with a similar idea, that we don't need to have this parallel corpora of original and simple text, but that we can check if something is simpler or more difficult just using a regular large corpora and to use word embeddings to retrieve similar substitution candidates, like synonyms based on word embeddings, and then have some frequency or like ranking functions how to find the best substitution candidate. Instead, the big problem is usually that the original systems are not available online, freely available. We made our system from 2015 freely available recently, and also like allowing it to be used for any language pretty much. And Gustavo made implementation of all these previous lexical simplification systems, I mean, as good as he could to re-implement systems based on what was given in the description of the paper. So on his web paper, on his GitHub, you have the tool that implements all these different systems if you want to try them out. So, I would say that currently these unsupervised state-of-the-art lexical simplifications are these two systems. I mean, either ours or Gustavo's and Lucy's, I think it's very similar, and it's very difficult to say which one works best they were trained on slightly different corpora. The word embeddings were taken from different corpora, and they were tested on slightly different evaluation data sets. Pretty much they have the similar idea and the similar performance. So what is the main idea? The big plus of these systems is that they are unsupervised, so we don't need simplified data, and we don't need parallel data, and we saw that that's a big problem. And as we don't need that, we have a better coverage than in the previous lexical simplification systems that were supervised, and therefore they had a lower coverage. What is the problem with this system? Is they are simplifying only single words, not multi-word expressions. So no multi-word expressions, no longer phrases, just isolated words can be simplified. And at that time, at least, we had a big problem with antonyms, because the word embeddings cannot well distinguish between antonyms. They're right appearing in a similar context, and then you have lots of change of meanings just because you replace one word with its antonym instead of its synonym, because from the point of view of word embeddings, we couldn't distinguish which of the two. So the main idea is that the simple words are also present in non-simple texts. You don't need to have really simplified text, but you could assume that even in non-simplified text, those words that are more frequently used, they are probably simpler. And if some word is rarely used, it's probably very specific and might be difficult. So what we need for this approach, we need a good semantic similarity measure, so how to retrieve possible substitution candidates, and we need a good measure of word complexity, how to rank the substitution candidates and choose the best one that we want to replace the original word. So how we choose the simplification candidates? Well, we focus only on content words, so we don't take into consideration, of course, the articles, prepositions, and other words, so just the content words, nouns, verbs, adjectives, adverbs. And we use 200-dimensional glow vectors pre-trained on English Wikipedia and GigaWord 5 at that time. And then for each content word, we select 10 most similar content words by using the cosine similarity between the word vectors. And we exclude, of course, morphological derivations of the same word. Once we have these 10 most similar words as a substitution candidates, we need to rank them. Our approach is all-in-one approach, and we practically rank them at the same time by all three criteria, and then we use the average value. Well, you will see Gustavo and Lucia, they use it as a modular approach, and for them, each of these ranking procedures is a separate model. So what we do, there are three ways in which we compare our target word with the possible substitution candidate. One thing is the context similarity, where we take symmetric window of size 3 and we check practically the word embeddings for our target word and the words in the context, trying to preserve the original context, to preserve the meaning when we do the substitution. For simplicity, we use a very simple measure, which is a frequency in a large corpora. This we did just because we wanted to try the idea of using word embeddings, so we used frequency as the simplest simplicity measure. But actually, if you want to adapt such a system to different target populations, this is the part that you need to change. Here, our assumption is that if it's more frequent, it's more simple, but for example, if you simplify for dyslexic people, it's not about the frequency maybe, but about the combination of letters within the word. So practically these functions should be adapted depending on your user needs. What is simpler for someone is not necessarily the frequency, might be the ambiguity of the word, or might be some other function or combination of functions. And finally, to make sure that we again preserve the grammaticality, we use the language model to see if we can substitute a target word with a substitution candidate. And then to evaluate the system, we had the automatic evaluation on 2 different tasks. The first one is what I mentioned before, the one with the Wikipedia and the target word and 20 substitution candidates proposed by Amazon Mechanical Turkers. The second task on which we evaluate is the Seneval 2012 task, where you have a sentence, you have a target word, and you have 4 possible substitution candidates, 4 possible simplification candidates. They all fit the context well, they all preserve the meaning, they all give the grammatical sentence, and the task was to rank them based on their simplicity. And for that task, the dataset was collected by asking non-native speakers to rank these 4 substitution candidates. So that's for the automatic evaluation. We try our system, test our system on these 2 tasks and see how it compares to the state of the art. And of course, we also do the human evaluation to check the grammaticality, meaning preservation, and simplicity of our sentences now in the whole context. So for the replacement task results, the one in Wikipedia, these are the original evaluation metrics that they used in the paper in 2014, precision, accuracy, and change, like the number of percentage of target words changed by the system. And here you see, this is the state-of-the-art unsupervised system before, the one that was using edit histories of the Wikipedia. This is the state-of-the-art supervised system at the time, and this is our system. And you can see, in terms of precision, this supervised system is slightly better. It is better than ours. Precision is similar to the one that is unsupervised. In terms of accuracy and the percentage of changed, so this practically you can look at it as a coverage of the system. Ours is definitely way better than the unsupervised system, and it even improves over the supervised system. On the second task, on this task of ranking, so if you have a target word, you have 4 possible substitution candidates which all fit the context and preserve the grammaticality. Which one is the simplest? So you need to rank them 1 to 4. This evaluation is done using the Cohen's kappa, that is the official way of evaluating the shared task as well. So here are the results for the baseline random system, baseline frequency based system. This is the winning system in 2012 for that shared task, and these are results for our system. So we managed to get much better results than the state of the art at that time. The results of the human evaluation, well, here it's an important point again to mention for the human evaluation. As I said, we evaluate it usually on the 1 to 5 level scale for grammaticality, simplicity, and meaning preservation. We here added also the column, the percentage of sentences which were actually changed. So out of our whole test set, in how many, in which percentage of sentences there was at least some change introduced by the system. Because the main problem is that supervised systems rarely made any changes. They might change one word, or very often not a single word because they have a bad coverage. So here, if you have a look, these are the original sentences. They are not ideally grammatical. Well, the sentences are from Wikipedia or from news articles, so they might not be perfect in their grammaticality. Their simplicity was assessed around 3.4. And this is the assessment of their manual simplifications. I think here we are using Wikipedia, so the manual simplification is actually their counterpart in the simple English Wikipedia. This is the state-of-the-art unsupervised system before that, the one with the edit histories. This is our system. If you look at these two lines here of evaluation, then you would see that the previous system preserves the meaning better. But why is this the case? Because this is calculated, this is meaning preservation score on the whole test set. But what you can see here, this system had a low coverage. It only changed 17% of the sentences. Our system made changes in almost 69% of the sentences. What that means, if you don't change anything in the sentence, of course your meaning preservation score will be 5. Because when you compare original and your output, which is exactly the same as the original, you will get a score 5. And that's something that is important to keep in mind when you do human evaluation. Meaning preservation score and grammaticality score should be calculated only on the sentences that were changed with the system, if you really want to be fair when you compare two systems. Otherwise, the system that doesn't do anything and the system that does some changes will then favorize the system that doesn't do any changes, because their grammaticality and meaning preservation in most of the sentences will be the highest. And that's something that, no matter how simple it looks and it's obvious, people sometimes forget when they do the evaluation, and then you have artificially high scores. So here are the results if you just calculate the grammaticality and meaning preservation scores and simplicity scores for the sentences that were actually changed by each system. And there you see that our system preserves the meaning better, that is much simpler than the previous unsupervised system, and that the grammaticality is much better. But still, how good is that? I mean, the numbers look very good, but this is how it looks in practice. And we talk about automatic text simplification. This is where we are right now. So this is the original sentence. This is the previous unsupervised state of the art. I mean, this is not, I'm honest when I say this is not really cherry-picked. It's pretty much, this is how it looks. The previous unsupervised system will change maybe one word in a sentence, even if that. Our system will typically change 2 to 3 words in each sentence. So this is kind of a representative example of what is happening there, not really cherry-picked. So this unsupervised system has often the wrong substitution, like the contrast between a high level of education and low level of political rights became the separate between a high level of education and low level of political rights. I mean, this system in itself doesn't have so much of the language modeling and checking for the context and goodness of fit, let's say, for replacing, so it makes these wrong substitutions. Our system, on the other hand, had these 2, let's say, okay substitutions, particularly or especially, defend or protect. You can argue that it might be simpler or not, but in general it has the same meaning, and I think it is a simpler version. But this is the problem that you get with using word embeddings. Refuse and ask are used in a similar context, therefore the word embeddings for it will be very close by vectors in terms of cosine similarity. But as you see, it changes the meaning a lot. And similar things would happen with cold and hot, or warm and cold and something like that, because one might be more frequent than the other, and their cosine similarity will be very close by because they're used in a similar context. So that is something that definitely needs to be addressed if you want to use word embeddings for lexical simplification. So as I said, there was this other system proposed a bit later, with a similar idea of using word embeddings for unsupervised lexical simplification. What is the difference? They use a context-aware word embeddings, so they used also part of speech tags when training their word embeddings, so try to address word sense disambiguation, let's say, in a way. And they use the modular approach, so they had separate models to detect the target words, substitution candidates, to rank the candidates, and then they were evaluating their system step by step for each model, while we just had one joint evaluation. And they, for training their embeddings, they used a corpus of subtitles. They were saying that it's probably closer to the spoken language and for everyday language than the GigaWord or Wikipedia corpus that we used. And here are the results of their evaluation. So this was the unsupervised previous approach. This was the supervised state of the art. This is our system, and this is their system. And according to this evaluation, their system performs slightly better. But then, as I said, it depends on the evaluation. Later, when they published a journal paper, then they evaluated different stages, and pretty much they are doing the similar stuff. It's very difficult to say which one is better unless the differences are very substantial, because the data sets are very small, the evaluation data sets, and human evaluation is subjective. Then I said there was the idea of using statistical machine translation to address text simplification. So that's another way of, let's say, lexical simplification, because mostly phrase-based SMT will do the lexical changes. What is better in this approach than in word embedding approach is that phrase-based SMT can address lexical changes of longer phrases, up to 7 grams usually, if you think about phrase-based SMT. So it's not focusing only on isolated words, but it might deal with multi-word expressions or simply longer phrases. So the idea is that text simplification can be seen as a monolingual machine translation task, where we translate from original to simplified language instead of from one language to another. And the first approaches were in 2010. So these are all phrase-based SNP approaches. Lucy used just standard phrase-based SMT approach. Woven then they tried to do the different re-ranking of the output, because they noticed that the default translation that is given by the system, the first translation, is not often making any changes. But then if you re-rank the output, if you take several translation hypotheses, maybe some lower rank hypothesis can actually be better simplification. Why? Because machine translation is tuned inside with the BLEU score. It's supposed to be for bilingual machine translation, and to preserve the meaning, it has the BLEU score inside, and then the best hypothesis ranked by the system is usually preserving the meaning well, which also means that it doesn't do many changes. But if you look for several hypotheses you have and you re-rank the output, then your system might give better results, make more changes. That's what they've done here. You will see later we are talking a bit about how BLEU scores are not really reliable. But then there were also attempts at using statistical-based machine translation in 2010 and 2016. I'll mention them briefly. And then starting from 2017, there were neural machine translation approaches. So what is important to keep in mind when you use phrase-based machine translation for text simplification? Well, there is a big difference between doing monolingual machine translation and bilingual machine translation. First of all, as you're using this phrase-based SMT as a black box, it really depends what you feed into your system. What is your training data set? So there are different types of transformation. Maybe you have just lexical change in your training data set. Maybe you have sentence splitting. Maybe you have very strong reordering and very strong paraphrasing. Usually in these approaches, you just put everything there as a training data set and then you see what is happening. So what we try to do here, thing is that we tried first to use phrase-based. So phrase-based machine translation was done by Lucia Speci in 2010, first for Portuguese, from this big project for Brazilian Portuguese, using as a training data set 4,500 sentence pairs, and their results were very good. It seems that this phrase-based SMT approach to text simplification works really well. Then we tried to do the same. There was another work done for English using English Wikipedia and Simple English Wikipedia as a training data set, and it looked like it works well. But that was a huge data set of 160,000 sentence pairs. And then we tried to do the same for Spanish using our simplex corpus that had 2,000 sentence pairs. And we got horrible results. The output was completely damaged, it was not grammatical, it was not preserving meaning, pretty much complete noise. And we thought that maybe the reason is just because we have such a small training data set, 2,000 sentence pairs. But then, you know that for Portuguese it worked with 4,500 sentence pairs. It's not such a big difference in the size of the training data set. So what we did, we took 2,000 sentence pairs for all three. So the whole data set that we had for Spanish, and then we randomly chosen 2,000 sentence pairs for Portuguese and 2,000 sentence pairs from the English data set to see what will happen if we have the equal amount of the training data set. And if you would look at the scores, of blue scores at the end and human evaluation, still the same hold. Portuguese was done very well, English slightly worse but still well, and Spanish was done really bad. So we looked what is happening there. Obviously the size is not the problem here. And then we analyzed the training data sets in terms of their sentence-wise blue score. So these ranges here that you see, they're practically telling you how similar are the two sentences for each, the sentence pairs that you have in the training data set. So if you're in the range 0 to 0.3, it means those very severe paraphrasing is there in the sentence pair. But if you're somewhere here, it's probably just one lexical substitution or maybe just a sentence splitting, because then the n-gram match in your sentence pair is very high. And what you can see here is that in the Spanish data set, we had around 86% of sentence pairs was with very heavy paraphrasing, very heavy reordering and substitution and sentence splitting, everything. And less than 1% of sentences was in this middle range, which you could assume that these are the most common transformations that you want to model. In Portuguese, the distribution of these similarity scores was pretty much similar across all these similarity intervals, while for English you had a bigger portion of very different and very similar sentence pairs, and then equally distributed somewhere in the middle of the range. What that tells you, you cannot just do whatever, put the training data set and expect that it will work well. So the thing is that it depends what you're training on. Phrase-based machine translation is not really made for doing these heavy sentence reorderings. And that's why if we try to learn that, what we tried with our Spanish data set, we got a very bad results. Because what happens? Look at here. So we have the Spanish, Portuguese, and English. This is the percentage of sentences where there were absolutely no changes. So in the experiments on the English, they said 65% of sentences had absolutely no changes. So the output of the system was the same as the input. In Portuguese experiments, 40% of sentences were not changed. And in Spanish, only 4% of sentences didn't have any changes. So 96% of the sentences had some modification with this system. This is percentage of sentences with only one substitution. Again, 40% of these sentences in Portuguese and only a few sentences in Spanish. But percentage of sentences with more than one substitution is 91% for Spanish and only 2% for Wikipedia. What this tells you? What is the chance of being grammatical and preserving the original meaning? If you have almost no changes or just one change per sentence, it's much easier to preserve the original meaning and to preserve grammaticality. If you start having many substitutions, you might change the meaning if the substitutions are not correct, or you might destroy the grammaticality of the sentence because all the substitutions altogether don't make the grammatical sentence. And this is like the percentage of sentence splitting that were achieved and so on. So what this tells you? Be careful when you use phrase-based SMT. If you want to model heavy transformations, phrase-based SMT probably is not the right way. It's trying to do phrasal substitutions and it learns lots of noise on such a small data set. It tries to apply so many substitutions, but lots of them will be incorrect because it doesn't have enough training data set to filter out the noise and to have a good statistical estimates. But if you use the data sets that don't have such heavy transformations, like this one for Portuguese, which was made with the idea that it will be used for machine translation approach, so no heavy transformations, then it works well. You can learn these kind of transformations fairly well with phrase-based SMT. And the similar for English. Of course, these three data sets are for different populations. The Spanish data set was made for people with Down syndrome. They need heavy transformations. You shouldn't change the data set. You should change your approach, how to model the system which should deal with the heavy transformations. The Portuguese system was made for people with low literacy levels, and for them this kind of transformations might do well the job. And the English one is from Simple English Wikipedia. It's for everybody. Again, it's not such a heavy transformation what is needed to be modeled. Another thing that we notice that is problematic is that everybody report the blue score. As I said, this is the machine translation evaluation metric. This is practically the n-gram matching between your output and the gold standard. This metric has, it's heavily disputed also in machine translation that it's not the best one, but they don't find anything that works much better. But it's not so problematic for bilingual machine translation, but it's really problematic for monolingual. Why? You're comparing your output with the gold standard. Imagine you're translating from English to Russian. If your output is the same as your input, your output will be English sentence, and you're now comparing it with your Russian gold standard. And it will be very low n-gram match. So if your system doesn't do anything, it will be penalized. This blue score will be very low. But when we talk about monolingual translation, what happens? I have the original sentence in English, my output is also in English, and my gold standard is also in English. My gold standard is a simple English sentence. But if my system doesn't do anything, if it just copies the input sentence, this might still be very close to the gold standard. Because if my test set has this sentence pair where the original and simple sentence, they differ only in one word, then this blue score will be very high even if my system doesn't do anything. And that's what made people think that this phrase-based SMT works really well for English, especially where you saw that in 65% of sentences there was no changes. Of course, that blue score that went very high, if in your test set you also have the sentences which are very similar, so even if the system doesn't do anything, your blue score is very high up. But if we use the blue score on the Spanish sentences, in the test set it's similar situation as in the training data set. Lots of sentences are very different. So if our system doesn't do anything and produces the same output as the input, now when you compare it to the gold standard, there's a big difference because in that data set, original and simple sentence are differing a lot and the blue score will be low. And this is what we tested here. We did experiments for English, because for English we have this large English Wikipedia and simple English Wikipedia data set, so that you cannot say it's because the size of your training data set is low. So we trained many systems, so this is the size of the training set with 2,000 sentence pairs, 4, 6, 8, and 10,000 sentence pairs. We were also checking the similarity of the sentences in our training data set. So these are the ones with the heavy transformations, these are the ones with the very small transformation in the training data set. But what are these results? This is the result on the Wikipedia test set, and this is the result on Encyclopedia Britannica test set. So the Wikipedia test set is a similar test set like the training data set here. So this is the sentence pair from English Wikipedia and simple English Wikipedia, which are sometimes similar, sometimes are not. Encyclopedia Britannica is a test set of around 600 sentence pairs. These are original Encyclopedia Britannica text, and they're simplified versions for children. And when they're sentence aligned, this data set has much stronger transformation. Simplification for children is not as heavy, but closer to the transformations for people with cognitive disabilities or some special. So it has lots of paraphrasing, lots of reordering, and lots of lexical substitution. So what we found here, so these are the results for exactly the same models, just tested on 2 different test sets. And the blue scores on the test sets of Wikipedia are around 60, and the blue scores on Encyclopedia Britannica are about 14. We are talking about the same models. So how do you interpret that your blue score is 60 or your blue score is 14? It's actually not telling you how good is your system. It's actually telling you how your test set looks like. Are the sentences in your gold standard in your test set similar or they are not similar? So this made us think, should we really use the blue score? I mean, you can compare 2 systems. If you're comparing them on the same test set, okay, it might help you if you have these systems here, they're all on this test set, and we have another text simplification approach, again tested on Wikipedia test set, we might compare this. But if you have 2 systems that are tested on different test sets, you should not compare their blue scores and make conclusions based on that, which system is better and which is worse. And then we checked with the appearance of Newsela dataset and sentence aligning this Newsela dataset, the one with the news articles on 5 different complexity levels, manually simplified, so better quality dataset than Wikipedia. What happens with the phrase-based SNT approach? So this very simple, here we use just the basic Moses phrase-based SNT without any changes, like a black box. But just we train it either with just the Wikipedia data set, or we add Newsela on it. This is Newsela just for neighboring levels, so these are not heavy transformations. This is all Newsela levels paired, so this one has both small transformations and very heavy transformations. And here is New Zealand, but okay, this is for different kind of sentence alignment in New Zealand. But we compare these phrase-based SMT approaches to the state-of-the-art syntactic-based machine translation approach and to our unsupervised word embedding-based lexical simplification. And what you can see here, this is the number of changes and percentage of correct changes. Okay, these are the language models that we use for phrase-based. But maybe what is more important is if you look at the scores for grammaticality and meaning preservation, these are the scores on 1 to 5 scale. For simplicity here, we change the way we evaluate. As we were saying before, this simplicity score on the scale 1 to 5 is very subjective. So instead of using that, we gave people always a pair of sentences and asked them, is the first sentence much simpler than the other one? Is it simpler than the other one? Are they equally difficult? Is one more difficult or much more difficult? So they always had to compare two sentences relatively to each other, and this is much better in terms of inter-annotator agreement because, as I said, humans will more likely agree if one sentence is simpler than the other one than giving them scores on the absolute scale. So there the scale goes from -2 to +2, -2, -1, 0, +1, and +2. So we always show them original sentence and the simplification. We give the order randomly so that they should not guess which one is original and which one is simplification. But these are the scores that you have for that kind of evaluation. So the positive score means that simplification is simpler than the original sentence. Negative score would mean that the simplification is actually more difficult than the original one. As you see, none of the systems, even this state-of-the-art, this one had a very good, scores on their evaluation on each isolated change. It makes lots of lexical changes, but then the problem is that altogether they don't seem to make much difference how you perceive the sentence. Is it more simple? Is it simpler than the original or not? While these phrase-based SMT systems seem to work fairly well in comparison to this. I wouldn't say these work great and these are bad. I think they're all bad. These are just less bad, if you want me to be honest, if we talk about automatic text simplification. But it still helps us understand a bit better what is happening there and which way we might want to go in future. Okay. So this will be a system that is quite different than what you saw so far. But I find it very interesting. It was really pure curiosity from our side. As you saw, I said the problem is you either need a big number of handcrafted rules or you need a huge parallel datasets normally for text simplifications. So we wanted to have the system that is not just doing lexical changes, but both lexical and syntactic, but also do some content reduction. And how this happened, I was doing my PhD in text simplification, and I had a friend who is doing PhD in event detection, factual events from the news stories. And as we were sitting in some conference, coffee break, and I said, well, actually your system is what I need, because if I want to do the content reduction, if I want to see what is relevant and what is irrelevant in the news, I might use your system that tells me which are the factual events, and these are for me relevant stuff that I want to simplify from the news, and helps me to distinguish between irrelevant and relevant stuff. So what is the core idea of this system? That if there is a factual event, then that's a relevant piece of information in the news text. And descriptive parts of sentences or fully descriptive sentences are not informationally relevant. So as I said, for people with cognitive disabilities or anyone who needs also the shorter version of the text, not only simple, you want to eliminate non-relevant parts. So this system is the first one that actually has this semantic background. If something is relevant, then keep it and simplify it, and if it's irrelevant, don't simplify it. And as I said, if you first do the summarization and then simplification, you might have a problem because summarization might make your system your text even more dense and more complex, so it's even more difficult to simplify it. And if you try first to simplify lexically and syntactically sentences, you will have the grammatical and meaning preservation errors, and then you cannot apply summarization. So the idea here was, let's do this jointly. We use the event extraction to find most relevant pieces of information, and then directly on these we will apply the syntactic simplification. And we had two different simplification schemes. One is sentence-wise, the other is event-wise. What means sentence-wise? It means if I have a sentence in the original news story in which we detect 3 factual events, it means that in my simplified version of the sentence, I would still have just one simplified sentence which would contain all these 3 events. I will just delete the parts of the sentences that don't relate to any of these 3 sentences, of these 3 events, which means the sentence becomes shorter, but still it's one-to-one. For one original sentence, I have one simplified sentence. In the event-wise simplification scheme, we say each event will become one simplified sentence. So if my original sentence had 3 events, this will result in having 3 simplified sentences coming from this one. For each event, we will generate one simple sentence. So in this way, we are not only doing content reduction, but also sentence splitting at the same time. And for the evaluation, here we applied readability, because we are actually here simplifying the whole text, so it makes sense to do the readability assessment. Of course, we also check for meaning preservation and grammaticality first. And then we had a human evaluation on the sentence level for grammaticality and information relevance. Here we didn't use this meaning and simplicity scores as used before. Why? Because we are deleting some parts. Of course, meaning is not fully preserved if you delete a certain part of the sentence. So instead, we had to modify the way we instruct humans to assess simplicity and meaning preservation. We said for meaning preservation, give it a highest score if all relevant information is preserved. You don't care that irrelevant information is deleted. And for simplicity, you need to reward that irrelevant information is deleted. You will penalize if irrelevant information was preserved in the simplified sentence. So here is the example of the system. If we have such an original sentence, this is from the news story. So some guy, Libyan intelligence officer, who was convicted in 1988, Lockerbie bombing, has died at his home in Tripoli 3 years after he was released from Scottish prison. And then there is another sentence there. So the first sentence, you see, has several events. He was convicted for this bombing, he died at his home, and he was released from the prison. So in blue you have what are practically the main events. Then in red you see the subjects, and green is the temporal part of the event, and this is location of the event, this other color. So what we want our simplification to do something like this. This guy, convicted in 1998 bombing, has died at his home. 3 years earlier, he was released from the prison. So practically, we have the sentence splitting, and you see all these gray parts, which are not parts detected by the event detection system, they are eliminated. So we have a shorter version, which is more to the point, and it has shorter sentences. So, I mean, you can say that this is unsupervised system from the point of view of text simplification, because you don't need a parallel data. But the event extraction system is supervised. I mean, the event extraction system that we use here as a black box it's actually a supervised system. So if you want to apply this simplification strategy for another language, you don't need to have parallel data to text simplification, but you need to have a good event extraction system for the language. Or if you want to go to another domain, you need to have a good event extraction system for that domain. Once you have event extraction system, there is not much that you need to do. Because there is, once you extract the factual event mentions, then you just apply these simplification schemes that I mentioned. We have two, event-based and a sentence-based one. Each of them has only a few handcrafted rules. I mean, these rules are more like, I have event mentions, and as you will see, if there is something like bombing, then it should not be sentence, it would not be a separate sentence, because this kind of event cannot stand in a separate sentence. So it's practically unsupervised text simplification system, preserves, it performs sentence splitting and content reduction, and the only thing that you need to worry about if you want to apply it to a different language or different domain is to have adequate event extraction system. So here is example how the system actually works. So here is the first sentence, the same as in the previous example. The second sentence didn't have any events, so I removed it from here. This is how the sentence-wise simplification would look like. So as you see, it's very colored. There are just a few gray words that are not part of event mentions, but they need to be there for the grammaticality of the sentence. This is why you have those few rules, what still to keep from the original sentence. But you see that all events are still in one simplified sentence. This is a shorter sentence than this one, more up to the point, but all events are in the same sentence. In the event-wise simplification, each event that can stand on its own is in a separate sentence. As I said, bombing is not something that will stand on its own. It's very strange. So we have three simple sentences. And the last version is if we add a pronoun and upper resolution on top of the event by simplification. So all this he would actually be replaced with an extra person. So we evaluated it using readability, so that's automatic evaluation on the text level, and we had evaluation of grammaticality and information relevance on the sentence level. We say evaluated on the text snippets. Why? Because we have one original sentence or a few, and then we have the simplification, which might be, again, a few sentences. As a baseline, given that there were no similar approaches before that would take this semantic idea behind the text simplification, we thought of the baseline that would be just to retain the main clause of the sentence and discard subordinate clauses. That would be the closest and the easiest way to do a baseline. So you parse the sentence and just keep the main clause because it is probably the most relevant part, and you discard all the subordinate parts. So here you have the results of the human evaluation. This is the interannotator agreement, which is kind of okay for text simplification. This is pretty much as good as you can get in human evaluation because it's a very subjective task. And here you have the results for grammaticality and relevance. Here we were just using the scale 1 to 3. Actually, we used the scale 1 to 5 originally, but then we merged 1 and 2 as one mark and 4 and 5 as the other mark. Because actually this is like bad, neutral, and good if you think about it. So the baseline, where we just have the main clause based on the parse, gets quite good grammaticality, so 3 is the best. but the relevance is not so good as you can assume, because by deleting subordinate clauses, sometimes we delete something important. The sentence-wise schema had a lower grammaticality, had a bit better relevance, but the problem is grammaticality. Why? We keep all, let's say, 3 events in the same sentence, but as we are deleting some sentence parts, the grammaticality can be damaged. In contrast, when we have the event-wise schema, where each event becomes one simplified sentence, grammaticality is much better. Because now we don't, it doesn't matter that we deleted things in between if each sentence on its own sounds well. And the relevance is also a bit better. Adding pronominal and after resolution on top of it didn't make much difference. We were trying it, but there is, people don't agree, should you do pronominal and after on top of your simplification systems. We have contradictory findings. Does it help people or it doesn't? So we just wanted to see how the system would look like if we add it in case it's needed. And here's now the evaluation of, so this system said it does sentence splitting and content reduction. So it's lacking the lexical simplification part. So to make a fully fledged system, which would also do the lexical simplification, we coupled it with this word embedding lexical simplification system. Practically you have these 2 models. And we did it in 2 versions. MLex means we first apply the event-based simplification, and then on the output of that we apply lexical simplification system. And LexF means the opposite. We first take the original sentence, apply the lexical simplification, and then on that output we apply the event-based simplification. We were thinking that the order of applying these 2 models might make a difference, because if you think about it, the wrong lexical substitutions might trigger wrong event detections. And again, the mistakes in event detection and this sentence splitting can trigger different kind of lexical substitutions based on word embeddings, right? At the end, we didn't see much difference between this. There were some differences between the order of models, how we applied them, but it's not that one order is better than the other. One would have its own pros and cons, and the other one as well. And pretty much in total, they're doing similar stuff. So we compared with the state of the art. This is the hybrid system I was talking about that appeared in 2014. So it's a system that has rule-based syntactic simplification model and the data-driven lexical simplification model that was state of the art for these fully fledged systems that do both lexical and syntactic simplification at the same time. And the other system is also supervised system based on English Wikipedia, Simple English Wikipedia, that was proposed in 2011 that also applies both syntactic simplification and lexical simplification. And some small content reduction is present in both of these systems. There are no other systems that really had severe content reduction in their system. So here's an example. This is the original sentence, and it stayed unchanged in these 2 systems. They drove a patrol car onto the lawn in an attempt to rescue her. While our system will transform this sentence into they drove a police car onto the lawn. As you see, it deleted this second part as irrelevant. We can discover this is subjective feeling again what is relevant and what is relevant here. And it made a lexical change of a patrol car into police car. Here's another example. So this is the original sentence and it stayed unchanged by this supervised system. Johnson was rushed to hospital but died from her wounds, Goodyear said. This hybrid system did the syntactic reordering it was mentioned before. It says, Goodyear said Johnson was rushed to hospital but died from her wounds. Our system makes a sentence splitting and a lexical change. So it says Johnson was rushed to hospital, Johnson died from her injuries. The next example, my favorite one, this is cherry-picked, I must confess, but I was really amazed by how well it worked. Doesn't work that well, usually. So this is the original sentence. The ambassador's arrival has not been announced and he flew in complete secrecy, the official said. So the supervised system based on English Wikipedia and Simple English Wikipedia says, the ambassador's arrival has not been announced. This is like sentence splitting, but it has some grammatical error. The official said, right? Here is sentence splitting, here is some grammatical error. He flew in complete secrecy. So you have some reordering, the official said came here, and you have a sentence splitting. All the information is preserved. This is a hybrid system. It does again this reordering, who said what at the beginning. So the official said, again, grammatical error, the ambassador's arrival has not been announced, has a sentence splitting, and he flew in complete secrecy. But here what is interesting, in our system, that his arrival is actually he arrived in complete secrecy, and given that it's based on event detection, I think you would agree that these are pretty much similar events. His arrival was not announced, and he flew in complete secrecy. It's pretty much the same information that you're trying to say. Nobody knew about his arrival. So given that we are focusing on event detection, it was seen as two equivalent events, and then just one was here preserved. So the sentence becomes much shorter, and it just says he arrived in complete secrecy, which I think is pretty much exactly what this sentence is trying to say. That he flew. Now we can discuss again, is it important, did he come by plane or he came by bus or whatever, but in general the main information is there that he arrived in secrecy. And that's pretty much what you saw in these examples, that this is the state of the art of the fully fledged systems. Which one works best? It's again difficult to say. As you see, it depends what you want to achieve. You have the supervised system, you have the hybrid system, you have our system. Each one focuses on different things. If you really want to maintain all the information that is there in text, you should definitely not use the event-based simplification. So if your system is maybe pre-processing step for machine translation, or you want to use it for information extraction, you might not want to delete certain content. But if you want to focus on syntactic simplification, you probably want to choose either this hybrid system that has very good syntactic simplification, or our system that makes sentences shorter and lots of sentence splitting. Then again, if you want to focus more on lexical, it really depends what is your target application or population, which of the systems you choose as the best one. And that was pretty much it for the full-fledged, so the systems that have syntactic simplification. But then, as I said, given that everybody does this neural stuff, also we tried to do in 2007 neural text simplification. So if you were using phrase-based SMT, why not using neural machine translation systems in a similar way? Let's say again, this is a monolingual machine translation, and see how it works. And I was very skeptical about it. To be honest, I thought that it won't work at all, given that we have this, 200,000 sentence pairs only. I thought it would not be enough for something good for the neural approaches. But I was pleasantly surprised. So this was the first attempt in using sequence-to-sequence neural networks for text simplification. And this model, well, we could say that simultaneously performs lexical simplification and content reduction because we were using that English Wikipedia, simple English Wikipedia dataset that has full matches and partial matches. So those partial matches could actually model the content reduction because the system would learn how to cut certain part of the sentence based on those partial matches. The system also does some sentence splitting, but very rarely. I would say that this is a pure luck because it's very repetitive thing in Wikipedia, so it might learn this. What is great about these neural systems, not only ours, but later a few others neural systems appeared, they almost have a perfect grammaticality and meaning preservation. They don't make so many changes as those previous fully fledged systems, but when they make a change, they don't damage the outputs. So the way I see it at the moment where we are with this neural stuff, I think it could be used as a first step of simplification. And then on top of this, you might want to consider a different kind of simplification because this simplification will not damage your. It might not do anything, but if it does something, it will not damage. And it has a high level of simplification. Well, it does when you compare it to the state of the art. Why? Because, of course, if it preserves the grammaticality and meaning preservation, it's not so heavily penalized by simplicity score. I wouldn't say that it does so much more than the other systems, but as it doesn't damage, actually, if you compare the original with the simplified sentence, it will have better simplicity scores than the systems that damage the output. So as I said, as a data set, we use this English Wikipedia, simple English Wikipedia